Hello everyone, so welcome to my YouTube channel. So today I will be gonna start with the data structure that is the linked list. So let us start. In this video, we will be going to learn about what is linked list and difference between array and linked list, and also we will be going to implement linked list in Java also. So let us start without any delay. Uh, So before going to linked list, I will be going to give a the basic, introduction about what is array and how elements are stored in array. So in array, we all know that elements are stored at continuous memory location or contiguous memory locations. What do you mean by contiguous memory locations? Suppose like this. This is our memory locations. This is our array that consists of elements. Sorry, one, 2, 3, 4, 5, and 6. Sorry. So here elements are stored at continuous memory location. What is meant by continuous memory location? Suppose if this one is stored at memory location 100, and this next element will be stored at 104 memory location as int takes 4 bytes. So 4 bytes different with the byte difference of 4, the elements are stored. And next will be at 108 memory location. And similarly, this 4 will be located at 112th memory location. Similarly, this fifth 116. Continuous, like in an exam, students sit like according to their roll number one after another. Similarly, like in this, like that happens. Okay, continuous memory location, no extra space, will be empty between them. Like directly we will be going through 100 and 100 to 108. No, continuous with the exact difference of 4 bytes. Okay, so this is our array. So what is kind of you say drawback in array, that insertion and deletion kind of operation are costlier since memory locations are fixed. Okay, how uh, suppose we will be going to delete 4. Okay, so what we have to do, we have to shift this 5 here, and we have to shift this 6 to the location of 5. Okay, and similarly if we want to insert, suppose our array is filled, all the positions are filled, whatever we size declared at the time of array declaration. Suppose we have declared in Java how we declare an array. Here we specify the size, which is our 5. At max 5 elements should be there. Okay, and if we want to like insert here some element, it will give us error like array index out of bound, array index out of bound. Okay, we have to specify the size of array at the time of declaration itself, but this is not the case in case of linked list. Okay, we don't declare any size while declaring a linked list, it's not, a linked list is not a fixed size. We can grow it dynamically according to our need. We can shrink it according to our need. How we will uh, going to learn in next few minutes. So this is all about array. What is what are the points we learned about arrays? Array cannot be drawn dynamically. Why? Because size is fixed. Okay, size is fixed in array, and insertion, deletion kind of operations are costlier. Static memory allocation, we can say. Okay, but in linked list it is opposite. In case of linked list, in case of linked list, what happens? We can add elements dynamically. We will see how we'll add the elements. And next thing, in array we learn that elements are stored at continuous location. That means one after another. But in a case of linked list, this is not the case. Elements are not stored at contiguous memory location. How? Let us see. Suppose this is our linked list, and here I will give some memory locations like this is 100 memory location, this is at 200, this one is as 304, this one is at 400, kind of not continuous. Wherever it find free space, the elements are allocated to that. This is 600. Okay, anything. Here is pause, here is 1, 2. This is free, nothing is there. This memory location is free. We can, you know, like there are some free memory location between any two elements. 3, 4, and this is also empty. So no the fixed memory location. Any free memory allocation and memory space is there, that element will be allocated to that only. Okay, so next thing is that operations like insertion, deletion. Okay, so I believe is that it's all gone. Okay, no worries. What is that happening? Okay, so insertion, deletion is easier. We will see how insertion deletion happen in case of linked list in the next few minutes. So let us start. So this is all about difference between array and linked list. Now we will be going to implement linked list. How it is implemented? It's very easy. So let's start. In array, in array there are only elements, you know, and we can simply loop through elements because we know that elements are, stored one after another. We can simply loop through that. But how we will loop at in the linked list? Because elements are present. Some element is present, like suppose this is memory. So elements are present, like here is one, here is some free memory space. So here is two, here is three, here is four, here is five. How can we loop through elements? Okay. So to loop through the elements, we should know their addresses also. Where one is to connect them. Where is one present? Where is two? Where is three? Where is four? Where is five? To connect them, to make a connection between them, we should also know where the addresses of the elements. How we can store it? Uh, so in a linked list, suppose here is our element one, here is two, here is three. So we these are present at some non-continuous memory location, and we need to connect them. How we will connect them? Through their addresses. Suppose one is present at 1K memory location. One is present at 1K memory location. Two is present at 2K memory location, and this three is present at some 4K memory location or 3K memory location, and we can give. How can we connect them through the memory? How? So to make a connection between them, we can do something like this. We will store this address here, somewhat here, like this is element. We can store address to this address to okay here. So that this this is called as node, you know, in English. The this this is called a node where we store element and a kind of address here. So here what 2K will come, 2K will come, so that one will know that where 2 is present. Now one has clear indication that next element, to make connection with the next element, it stores, its location. So similarly, the connection is made between 2 and 3 also. Like as we made the connection between 1 and 2, similarly we will make a connection between 2 and 3 also. How we will store this 3K, the address of 3 here. Okay, 3K is stored here. Now, what is this? To Now there is no node after 3. So here we will store what null. Nothing is. This is the end. This indicates the end of linked list. Nothing is after this node is connected. Okay. Null indicates the end of linked list. Okay. So now the connection is fully made between 1, 2, and 3 by storing the addresses. So here one thing to be note that we should also store address of this first node somewhere, so that when we will look, we can look through v pointer, which will be just head. What is the work of head pointer? That it head points to the first node of linked list. So what this head is going to store? This is going to store the uh, memory location of first node, that is 1k. Head is going to store the memory location of first node, that is 1k. Now we have a pointer that is pointing to first node of the linked list, and this connection is made between the linked list. Okay, we can also have a like head, we can have a tail also, which is pointing to the end of the linked list. So this tail is going to store the address 3k, last node address. Okay, we have this linked list. This head, we can name it anything, but mostly we name it as head and tail. Okay, head is pointing to the first node of linked list. So we will gonna learn about what is the work of head and tail when we will be going to implement this. And this tail is storing the last node of the linked list. So what a node consists of? Okay, this is a node. This specific is called as node. This whole 1 and 2k is called as node. Okay. So what a node consists of? Node consists of a data and address. Data like 1 and address like 2k. This single node. Okay. This single node. So some key entities are node. There is their head is there, that is going to store the points to the start of, we can say, linked list, and tail points to end of linked list. So this much is these are some key entities of linked list. I hope this is clear to you. So now let us see in the programming point of view, how will we going to implement node implement, how will we going to make a node, how will we going to implement English. Okay, so this node is we can make this node using have any data structure which will be going to store element and its address also. So we can make our own data structure. We can build our own data type. Data type. So we can build our own data type. That is class. Okay, class node. We can name it as node. What is this node going to have? This node is going to have one data and one address. Address. So what is the type of the address? Okay, what is this type by the type, whatever this address is going to store. Address is going to store Address is pointing to a node type, a node, a class of type node. So this address is pointing to the class. So this address is pointing to what a type. There are some types, int, char, boolean. These are pre-built type and class is made by us. What is the name of that class? We have given node. Okay. So this address is pointing to a node, a class of type node. Okay. Type node. So this address is going to store a node type of class. Okay, so the type is node because it's pointing to some node type of class that is storing data and address. Okay, and next thing is we can declare some uh, variables like head and similarly tail, similarly bus. So here the type is also node. Head is also pointing to a node type of class. Okay. So this we have built a simple node. We have built a node. Here is some data and here is some address. Okay.